I hope you enjoyed the last segment of this PowerPoint. We are continuing with the evidence of plate tectonics, the evidence of the continental drift. Now, here, you're going to have to bear with me for a minute. Here is the plates. Here's a plate. This is actually a separation. And here's the plate. We've looked at these diagrams already with the convection currents circling and moving these plates apart. So when these plates separate, hot magma comes up right here at the mid-ocean ridge and cools. Now, let's take a little sidebar. The Earth has a magnetic field. Okay, we have a North Pole, we have a South Pole, we have a magnetic North, and we have a magnetic South. Now, right now, magnetic North and magnetic South line up with the North Pole and the South Pole. But that is not always the case. We have what we call magnetic reversals. And that is literally like flipping the magnet upside down. So, where magnetic north is, if we flip that magnet over, would be magnetic south and the reverse on the bottom. So, what's actually happening is the magnet is flipping over. Magnetic north will end up by the south pole, and magnetic south will end up by the north pole. And this goes back and forth. Every 10,000 years or so, this happens. There's a lot of theories on why. From what I understand, it has to do with the iron and nickel inner core spinning within the iron and nickel liquid outer core. That creates the magnetic field, and sometimes the inner core will shift position. Again, just theories. But that's not what we're learning about today. What we're learning about today is the fact that when this rock, when this magma comes up and cools, solidifies, it actually cools and solidifies with the magnetic pattern. All right. So, right here, this is magnetic north for positive. This is magnetic south. All right. Now, check this out. See the white? That is the reversal. Now, what's important about this is if you look at this side and then you look at this side, they are identical. Okay, they're the mirror image of each other. Look, so right now we're in a normal, all right, magnetic north is north, magnetic south is south, and that's why it's solid. But then this will split apart. And that's why, look, we had a very short reversal here. That's why that white strip is very short. Normal, pretty short here and here. And look, there was a very long magnetic reversal. So you have these big white areas. Now, obviously, in the ocean, it's not white, black, white, black, white, black. But with special equipment, they can check the magnetic variation and it's north south or south north. We're just representing it here to make it easier. This is more accurately what they're seeing. Notice that here is 0. That's where we are now. And they do line up thicker, thicker. All right. Now, you'll also notice years on this one. Newest crust, oldest crust, and oldest crust. New crust is being formed here. Older, older out here. And every time there's a reversal, like the next time there's a reversal, it's going to be white in the middle here, or south and north reversed. All right, same thing here. Unfortunately, this does not work correctly, but as I click it normally, this gray would shift this way, and then white would be in the middle, showing you that the plates will diverge. I'll get into that term in a little bit, move apart, and you will see that